Hello and welcome to another video in the Open Computer tutorial series for version 1.3. My name is Lord Yoda and I'm here with Sanger, the lead developer of Open Computers, and Darka Total, our cameraman. In this video we want to take a look how you can communicate from one computer to another, or basically networks.
Yeah, networking. So we have here our computer X from last time, and I built a few more servers. So they look like this now, and they also have a network card. So this time we'll have a look at how we send network messages from computers to computers, or to servers, which are also just computers, and the different ways to do so. So basically there are two ways to transmit messages. The one is via cable, the other is wirelessly. So as you see, there's the normal network card and there's the wireless network card. And wireless network cards are, well, as the name says wireless, and you can control the signal strength of the network messages you send, so basically how far they go. And the higher the signal strength, the more energy it costs to send a signal. So starting with the simple network messages, let's get this server rack in here and power it up. So let's connect this server rack to this computer. This computer also has a network card in it, so wireless network cards also act as normal network cards. They are basically expansions to the basic network card. And if I have a look at the
tier 2.
Yes, exactly. If I have a look at the components here, there's one that's called modem, and the modem is the network card. So the methods on the network card, this one again, there's quite a few of them, and the important ones you have to know is open, to allow messages on a certain port to arrive, send if you want to send a message to a specific computer, or rather to a specific network card, and broadcast if you just want to send some data to any computer that's listening on a specified port in the same network. And now if I take a look at the server over here, it should also have a modem component, exactly. So now I can go ahead and say modem.open, let's take port 123. So that should now be open. I can test this with component modem.isOpen if I remember correctly. Yes, so it tells me, okay, 123 is open, so it's listening to messages from this port. Messages, when they arrive, generate events, so the way to actually receive messages from a network card is by pulling events. So I can go ahead and say event.pull modem something, I'm not sure, and then I go to the other computer that's connected to the server via this cable, and then I say component.modem.send, oh no, let's say broadcast because I don't know the address, and I send it to port 123 and I say hello, oops, not hello. And if I look at the output of the server, I then see, okay, there's a modem message, that's what the event is called. This is the address of the local network card, so it's this one here, the modem, the local one. The next one is the address of the network card that sent the message. The next one is the port. The next one is the distance from which the message was sent, which is for wired messages it's always 0, for wireless messages it's the actual distance, and then the actual data. Note that the actual data can be multi-part, so it doesn't always have to be just one single value, you can just pass multiple values in there. So if I go ahead and say, give a second parameter, which is then world, this would also arrive here if I pull now. So now I have two values given from this event. So if you prefer, you can do it this way, otherwise you can just pack it into a table and send that as one serialized parameter. Just note, so you can send the table directly though. The only supported values for network messages are basic ones, so string, Boolean values and numbers. Functions and tables are not directly supported. If you want to send a table to another computer, there's one API in Open Computers which is called serialization. Terrible word. This has two methods, serialize and unserialize, and it just takes a table and converts it to a string, and then it takes a string and converts it back to a table. So let's say I have some table with some values in it. This will then generate a string, which basically is just Lua code, and I can convert that back to a table if I so desire. And this is basically how you can send tables around the network if you want. Okay, so that's pretty simple, but one thing to note here is that if this were a computer, this connection here would probably be a bit of a problem, because both computers would then be in the same network, so the same component network essentially, which means they could see each other's screens and interfere with each other. So the normal way to separate these is using the switch block. This is a block that forwards network messages. So this separates the components by visibility. So if I have another computer over here, it will not see the screen of this computer. But if I send a network message from this computer, this switch will forward this network message to this computer. So if I go ahead and pull again on the server, and then I go ahead and send a message here again, but let's send it after some delay so I can actually see what's going on. We'll see that the switch emitted a light. So whenever a network message goes through a switch, or rather whenever a switch relays a message, it will blink. And on the server I then see, okay, the message arrived. Another thing to note is that the speed with which switches forward messages is limited. So switches have a GUI, and if I open it I see the basic values for the switch. So the first property here means how frequently the switch will try to forward messages. So if I go ahead and spam a bunch of messages on this computer, that will fill up the queue of the switch. So the queue is the number of messages currently stored inside the switch. So whenever a message arrived, it's put into the queue. And with the frequency of the first property here, this queue is worked through. So by default, 4 times per second, the switch will pull, this is the second value here, 1 packet from the queue and relay it to all other faces. So it will not feed it back to the side it came from, but it will forward it to all other faces of the switch. So if I go ahead and connect another one over here and send some more messages, we'll see that this one also highlights, but we know that the server also receives the messages. So basically this just forwards the message to all other sides except the one where it came from. And these values can be upgraded. So as you see here are the icons of the types of items you need to upgrade it. So with CPUs, you can increase the time, the frequency with which the queue is processed. With hard drives, you can increase the size of the queue, and with some RAM, you can increase the amount of packets processed per tick, so per cycle, not per tick. So you can speed up the switches if you want. So if you have some central message bus where you pump through messages from all over your base, for example, you will probably want to upgrade your switch, because if the queue runs full and more packages arrive, those packages will be dropped. They will just be lost. Okay, so that's it for switches.
I think also you should not make circles with the switches, right?
Yeah, that I'll talk about in a minute. Yes, exactly. One more thing about switches. So server racks, if we have a look at the recipe, you'll notice that there's a switch in the recipe for the server rack. That's not random. Server racks actually act as switches. This is also the reason why it's fine to directly connect a server to a computer via cable, as long as the side to which you connect the cable is not connected to some server inside the rack. So in this case, there is one, but it wasn't running, so there's no problem there. Okay, so yeah, so server racks act as switches. So if I put cables back and left and right and top and everywhere, the server would dispatch network messages on the other faces if one arrives on this side, for example. Actually, I can demonstrate this by placing one on the top and then send some more messages, and we'll see it highlights. So that's the wired messages. The next one would be the wireless ones. So in here I have a wireless network card, and this means I can send wireless network messages. Per default, the strength of the messages is at the maximum, I believe. So there should be, so yeah, there's set strength and there's also a get strength, if I'm not mistaken. And the strength is essentially just the distance of blocks that a wireless network message travels. However, the connection between a sender and a receiver for wireless messages, it does do a rough check for the path that is between these blocks. So if I have a computer that sends a message and a computer that receives a message, but there are a lot of blocks between the computers, so there's no air, but there is actual blocks between the computers, I will need a higher strength to actually reach the other computer. So what happens is that for each block that's between the computers, the hardness is taken and subtracted from the signal strength, and if the signal strength reaches 0 or gets below the 0, then the package is not delivered. You will notice if you try this that this is not happening all the time. That's because it's using some sampling to keep the performance acceptable. So basically what happens is if I send a message from computer A to computer B, and there's, let's say, a distance of 10 between the two, and there's 3 blocks that would block it, what actually happens, it doesn't look at all the 10 blocks between the two computers. It takes, I think, I don't know, 3 or 4 at random, and it specs those. So if it, by random choice, selects the air blocks, then the message will come through perfectly fine. If it selects all the hard blocks, then the message will probably not be delivered. So that's something worth noting and to always keep in mind when building your wireless networks. So let's say if you have a mountainous region, you might want to build some sort of antenna tower to put the switches on top to, not switches, access points on top to actually send the messages. Otherwise, you will have a lot of interference between your two endpoints. So talking about access points, the access point is basically an upgraded switch. It acts as a normal switch. It relays wired network messages, but it also relays wireless network messages. So if I put this over here, so not connected to anything, and then I send another message from this computer which has a wireless network card, then this access point will also start blinking because it relays the message that it received from this computer. The actual message that is received looks pretty much the same as for wired messages, except, as mentioned before, the parameter for the distance. So now I put down the... Well, actually, that I don't think will work. I actually need a wireless network card in the server itself. There we go. Whoops. There we go. So let's say I pull another event of type modem. I think it is message, but it doesn't matter. And then I send the... Oh wait, no, I didn't open the port. Haha. Things easy to forget. Let's try this again. There we go. So now this value is not 0, it's actually 4, which is 1, 2, 3, 4, the distance between the blocks. So basically the distance between the center of the blocks. And that's that. So now I could demonstrate that what happens if I set the strength of the signal to low. Let's say, no, I think it's just strength. Set this to 2. And if I now pull, whoops.
Oh, sorry, I wanted to pull.
Yeah. If I pull now and send the message, then we'll see that nothing arrived. So this basically just means the signal was too weak to reach the other wireless network card. And that's wireless network packets in a nutshell. One more block just to throw in here. It's not really networking related, but sort of is the power distributor. This also serves to separate component networks. So if I have something like this, then the servers in here will not be able to see this screen because it's separated by the power distributor, but the power distributor will make sure to pass along energy between these two networks. So this is also basically just a way to organize your networks. That's just on the side. Alright, so that's simple network messages and wireless network messages. Alright, so one final thing that was mentioned before, but not in depth, is the left setting on the top here in the server X, which is the internal or external switch setting of the server. So basically what this determines is how messages are passed along when they arrive at a server rack. So if this computer here sends a message, a network message, and it arrives at this server rack and it's in external mode, it behaves just like any other switch, so it distributes the messages to all sides of the server rack. So now it's in external mode, and if I send a message, it should now arrive at the switch in the back. So we saw it blinked, so it went through. If I set it to internal mode, on the other hand, this does not happen. So if I send a message now, it will not arrive at the switch on the back. The idea behind this is to allow to use servers in server racks as filters for networks. So you can basically have more control which packages go from what network to which network. And when it's in internal mode, what happens is that if a message arrives on any side of the switch, it is not broadcast to the other sides, but it is passed on to all the servers inside the server rack. So all of these servers that are inside the server rack right now got the message. So that's just something to keep in mind, regardless of their side setting. So this is ignored in that case. So when it's in internal mode, every message arrives on every server, but it doesn't get automatically repeated to the other sides. So you can control that using the servers inside the server rack. And when it's in internal mode, the servers can still communicate with each other. So you have the possibility to pass messages along from one server to the other. And for example, if I have one that's connected to the left and one that's connected to the right, if a message arrives, I can check, do I want to forward this message to the right, and then send it again from the server that's connected to the right. So that's the internal and external setting of the server X in a nutshell. Right. One final note, or something to keep an eye out for: if you build networks, you want to avoid having circles in your network. So if I have something like this, I have a circle, so a cycle. So if a message arrives in this switch, well, it will also arrive in this switch, and they will both forward the message on this side, so they will arrive again on the other switch, and that will forward it again back here. So essentially what you get if you have cycles is repeated messages. So if I just send one message now, oh wait, it's in internal mode, and this is bridged. So you see these blink again and again. So basically the messages are duplicated. So if you see that messages arrive multiple times, even though you only sent them once, you probably have a cycle somewhere in your network. And these can be relatively subtle. So for example, something to keep an eye out for if you have, say, a switch over here. Then this is also a cycle because the keyboard connects to the bottom. So this is pretty dangerous if you have this, so beware of that. Except for that, that's pretty much it. Right, I think that wraps it up for networks.
Maybe you can show how to get this message that says, I don't know, here, hello, and so on. How can you get parts of the message?
The same way as you do with any other event. So basically, simple Lua, just get a tuple result. So you get multiple result values. So where's the server with the big screen? This one. So basically, what you see here is the name, the addresses, and the other values. And the same way as you pull the first arguments, you also pull the several remaining arguments that were passed as data. So basically, I don't know, address, and then just underscore is just a convention for Lua for unused parameters and whatever, and then you say event.pull bottom or something, and then it's assigned to these to the variables with these names.
Okay.
And that's the same. That's not just for network messages. That's the same for all events. Yep.
Okay. Good. Then, yeah, be creative, and I think that's it for this time. Thank you very much for watching, and until next time.
Bye.
Bye.